Cool. Right. Hey, everybody. My name's Martin. We're going to, it's good to see you all again. So thanks for joining us late tonight. I was going to do some updates on GitHub Actions because I know, a lot of you are already using Actions and have sort of got involved with it, or maybe took a look at it earlier on and then wanting to come back and, see what's changed and what's new. Made some recent updates. I kind of just wanted to update you on, really. I'll start off by kind of covering the sort of introduction to Actions, do some power tips and talk about what's new, and then we'll play. My computer's been, with Teams running today, it's been super slow on doing the demo-y parts. So I've recorded a few GIFs and I've got them as slides, but then we'll jump into demos at the end. But I thought if I go through the slides first, and then that way get all the content, and then we'll see how it goes. If you want to get a hold of me, it's very easy. Martin Woodward at github.com or at Martin Woodward if you want to send abuse on Twitter. I'm getting buzzed as there's lots of comments coming in on Twitter already, so fantastic. Thank you very much. Feel free to get in touch if anything here is of interest. I work at GitHub. I'm on the engineering team, look after developer relations. And so, yeah, give me a shout if there's anything I can help with. I'm going to talk about GitHub Actions now. If you've tried GitHub Actions before, it's got some cool stuff. The thing I really like about GitHub Actions compared to something like Jenkins or Azure Pipelines or something like that is it's got the ability to automate anything, not just pushes to your repo or pull requests and things like that, but any kind of web event, any kind of event on GitHub that happens, you can add automation for it. In fact, I've got a colleague who's built some automation around issues. And what happens is you fill out a form in an issue, submit that form. Once the team approves it inside of the issue, it actually goes and creates an ARM template and deploys that infrastructure that you've filled that form out for, deploys it into Azure, creates a link to that, sets all the permissions up as well for your team, and then includes a link to that environment back into the issue so you can go in and start as a developer doing it. And that's how they're able to stand up infrastructure and things like that for developer teams without having to hand out subscription admin keys or subscription owners and all that sort of stuff. So you can really, automate anything with Actions, anything that you want to. So that's one of the reasons why I really love it. So not just CI/CD. Now it's with just like Pages, it's simple, and to get started, it's you can go use it straight away. It's pay-as-you-go pricing for private repos, so you pay per minute on a private repo. There are some free, quite a few free minutes included on private repos, and then you can pay as you want more. You can run it on your own hardware for free. So if you're running it like self-hosted runners, if you want to run your own build machines, then you can just go do that. You don't have to pay any extra for those. And of course, with it being GitHub, if you're using GitHub Actions with private repositories, with public repositories, then it's completely free, as you would hope and expect. Bear in mind that while GitHub's big and we have a lot of build machines, there is a finite pool of build machines that we have that we're constantly expanding that's being used for public repos. So we do see some people, using GitHub Actions for things, and you're like, maybe like a Lambda function might be a bit, or an Azure function or something like that might be better for this rather than Actions. Sometimes, you do, like, people are using automation for all sorts of things. So just know that if you're using this, it's great for open source and it's really, really good. But know that, this is designed for open source projects to use, really, rather than just using it as like a generic sort of compute automation pool and all that sort of stuff. But it's free, so go with it and go have fun. And then I'm gonna quickly jump on the what's super new that I thought was interesting since the last time I came and chatted with you all. But then we'll go in and we'll sort of recap Actions and go through some stuff. So first of all, Actions, we launched it in November 2019 was when it GA'd, and it's already the biggest CI/CD system on GitHub and the biggest CI/CD system we see in all of our data. And it's not just a little bit biggest, it's like bigger than all the other CI/CD systems combined now. So the growth in people using Actions has just been amazing to see. And we're seeing that as well in terms of the number of people creating actions, so creating logic to run within GitHub Actions. As of today, there was like 7,200 actions in the marketplace. There's more every second. And people are, going and building and plugging into the Actions framework so you can automate all the things using GitHub Actions, which is super cool. In fact, one of the things I did while we were talking like in the pages conversation then, chatting about what do we do with, SEO and readability and all that sort of stuff. So I did a quick search and found an action that you could run on a pull request to your Markdown. That's actually, I've not tried this myself, so I haven't looked, but it uses Google Lighthouse to give you an opinionated SEO audit of a page and give you some data there. So maybe you could hook up that action to the pull request when you were doing a new page and give you a score as to how good the SEO is of that and things. So rather than relying on Visual Studio Code plugins and things, you could maybe give that action a try. Anything you want, there's usually an action for it. Is the moral of that story. So lots and lots of new actions since you last looked, no doubt. New in December, we added a workflow visualizer. So I've got a screenshot of it here. We'll go have a play. Basically, you can see what's running and where it's running within your workflow. It kind of groups things together in dependent stages and things, but it allows you to have a nice view and go look across different environments, which is the next thing that we added. So the ability to specify these are jobs that are running for a specific environment, like QA, staging, production, that sort of thing. And then for each of those environments, you can actually add protection rules. So you can say only allow deployments to my production environment when they've been approved by the boss or something like that, or by a certain team. So you can start to do all those CD workflows as well within GitHub Actions now. Each environment has the ability to store secrets. We're going to talk more about secrets in a minute, and also manual approvals, as I've said, and other protection rules. Another sort of small thing, but it's a thing that people ask for quite a lot, and so one that I found very, very useful. You now have the ability to manually trigger actions from the UI. You don't have to just check files in to trigger the CI, to trigger actions. The number of times I've seen people, you go through, look for the commits, and you see people editing README files and things just to trigger actions again. Don't need to do that anymore. You can trigger actions manually if you want. And you can also delete workflow runs, which is great. I found out this morning when you're preparing for a demo and you want to delete all the failed builds and pretend that you're very, very clever and can make builds work first time. So, yep, great for preparing for demos. Some features on enterprise side. There's the ability to store secrets at the organization level. We'll talk again, drill into secrets in a sec. There's the ability to have self-hosted runners at the organization level. So not just for a project, but set up a pool of runners for your company or your team to use, and then share them across the projects, across the repos inside of your organization. You can label those and use that to help kind of select which ones that you're using. So say if you wanted to create here we go. Say if you wanted rather than using our hosted runners, you wanted an on-premise collection of Raspberry Pis that you were doing your runs on, you could build that as a pool and make it available, or set up the mainframe or something like that. Make it available as a pool for people inside of your organization to use if they wanted to. So that's cool. Yeah, so that's some of the cool latest updates. I'm just going to bring up chat here so that people can, if people are asking questions, then feel free to just, let me scroll down to the bottom. There we go, right. And if there's any questions about new stuff as well, feel free to just ask in the chat there. Okay, right then, next. Right, so let's just quickly show you in here how we go in and to get started with Actions. Actually, we can have a show of hands really. Who's already had a play with GitHub Actions in this call? I know there's lots of power users. Okay, quite a few, but not everybody. So to get started, super simple. You just come in, you go up to Actions, you create a new workflow, and you just go set it up. Now, in the magic demo world, the workflow you pick, we have some logic which detects your code. Obviously, in this example, the one it picks magically just goes and works for you. That isn't usually the case. Usually you have to do some, actual work and figure out what you want to do. But yeah, it's pretty simple to get started. It creates a YAML file which lives inside of your code base. So it lives inside of a .github/workflows folder. And so your CI, your CD logic is checked in alongside your code in the repository. If we look at the the why Actions is great, it's fully integrated with GitHub. So as long as your source code is stored on GitHub, then Actions is good for you. But if your source code isn't stored on GitHub or stored across a bunch of places, Actions probably isn't the right thing for you. So look at something like Jenkins or Azure Pipelines or something like that. It's fully integrated. It's obviously the leading CI/CD system now, and the ability to respond to any GitHub event, which is cool. One of the things I didn't mention is we host in the cloud build servers for you. We have these cloud hosted runners, and we have those for Windows, Mac, and Linux. So if you want to do a Mac build in parallel with your Windows and Linux builds, you can just go do that. You don't need to go buy a Mac Mini and have it running in the corner. You can just take advantage of ours, which is huge, for open source projects in particular, but also for doing iOS development, that sort of thing. It's also when you're doing those cross-platform builds, having the ability to do a matrix, so being able to say, hey, run this build for lots of different operating systems, lots of different versions of Node or .NET or Python or whatever. You can just set those up, and it will fire all those up in parallel for you, run them, and then allow you to pull the results back together. So we'll have a play of matrix builds in a little bit. And then we talk about it's easy to write and easy to share. This is one of the great things I love to do, because GitHub Actions is getting so popular now. Oftentimes when you go to your open source repository of choice, you can go see their Actions files and see how they're doing things, see how they're building. And so it's a great way of sharing. But Actions themselves, so a workflow is the file that runs things. The Actions itself are written and they're available as public open source repositories as well. And so if you want to see how an action works, you can go look at the source code of that, examine it, and then maybe fork it and create your own, which does similar but different things. So it's very easy, very open, very extensible. And then you can come in and mention about the logs. The logs are easy to, searchable and linkable, very straightforward. And the checks, that when an action's run, it just shows up in your UI inside of the pull request, and allows you to see very, very easily what's happened. So fully integrated, all that sort of stuff. So let's just we're just going to break down an actions file now, a YAML file. Again, I've done a slide version of this. I'm going to get through slides fairly quick, and then we'll go play and see how fast that is. But I wanted to make sure this part was working and we could see it all. So a YAML file, it's completely reusable components. We've got two elements. The file, the YAML file that you create, is what we call a workflow. So that's your actions workflow. And then inside of it, it uses actions. So they're the components that you're calling. So for example, Node 12 using Docker, that sort of stuff. So you can use an action from a collection in your workflow, is how it works. And then in the YAML file, you have the name, obviously, of the workflow. You have the triggers. And so do you want to do it on push? Do you want to do it on issue creation? Do you want to do it every time somebody pushes, does a change with GitHub Pages and does a deployment with GitHub Pages? Do you want to listen to the wiki? Do you want to listen to when somebody stars a repository? I had behind me over Christmas, about there, I had a Christmas tree set up. and whenever somebody put a star on my repository, it would light the Christmas tree up and then play a sound, and I would keep forgetting to switch it off in phone calls, and it was quite embarrassing. But yeah, you can do all sorts of things with actions. So and then the trigger is here. A job then runs, and then the job breaks down into steps. And then the steps, so you see each of these lines here is a different step. It's what you can think of it as. It's an array of steps. And then these step objects is, what does it do? What's it using? So this one here is using action/checkout, and this one's using V1. And that's how it works. Now you see this syntax here, action/checkout. Where's that syntax coming from? That's actually, in GitHub world, that's organization/repository. So everyone sees this actions checkout, and like people are doing that and think, oh, what does this do? But a little top tip for you: if you go to, and we'll just see if this actually works. Oh no, don't want to go look at my calendar. You'll see how hideous that is. If you want to come in here and go to no. There we go. Yeah, GitHub.com whack actions whack checkout. So I just action/checkout. You remember that's what we said we were going to use in our actions. Yeah, there you go. I told you. For some reason, Teams just really slowing down Chrome. There we go. So you see, this is the action that runs when you call action/checkout. This is the code, and you can go look up the source code. You can go see what it does. You can read the documentation, all that sort of stuff. And that at V2 or V1, that's the tag, the reference that you're referring to. So if you're wanting to go to, V2 is that one. V2, so we end up using semver as a way of versioning the labels, the tags for our action repos. But if you wanted to put a commit ID afterwards, you can put a full @commit ID, and then you would be locking to that particular, cryptographically secure version of that code that was running at the time that you inspected it, all that sort of stuff. So that's all that is there. It's org name /repo @version. You can forget all of that though. That's just a power tip for people, but it's fairly readable otherwise. And then, as I say, they run on different machines, and you can run them on a whole VM. And actually, on Linux, you get a Docker container inside of a Linux VM. So you get full access to the machine. You've got full root access, full admin access. You do what you need to do in that box. You can install prerequisites on the machine, all sorts of things. Now, as I mentioned, we've got let me just see what I kicked off here. The steps, when you're doing these steps, they all run within that same virtual machine and same file system. So inside of here, you can guarantee that the stuff you did before is still there. But with inside a job, it splits the jobs across machines and kind of destroys the machines before it creates them again. So if you want to do stuff that's reliant on stuff being in the file system ahead of time, then it needs to be within the same job as a sequential set of steps. I mentioned triggers. If you want a list of all of the triggers, then just go along to the help article. But there's triggers for anything in GitHub you want to do, plus a few other things. We're going to do some of these in my tips, but here's an example of one. We've got a cron trigger, so run on a particular schedule. And then we've got a few other ones as well, like webhooks coming in and manual triggers, that sort of thing. So we're going to cover those in our tips later on. And then the steps is where all the stuff actually runs. Basically, a step either calls another action, it runs some command line script, or it can run a multi-line script. They're basically the three things that you do, you know what I mean? And if it's calling another action, then you pass it some parameters. The vast majority of times you're just calling an action, passing some parameters. But if you just want to quickly run some code, execute some code, then you can just go run a script. You're more likely to make your actions cross-platform though if you're doing it this way rather than hard coding Linux scripts and things like that, or PowerShell scripts. All right, let's talk about secrets. So a secret is stored in the repository typically. you can have them stored at for the organization, and then they're stored fully encrypted on GitHub. You can add them and you can update them, but nobody can read them. The only time you can read them is when you get past them during an actions run. You can't go see them in the UI. And then, so it's great for putting in things like, AWS or Azure keys, that sort of thing. You know what I mean? You can put, that's where you put your secrets. If you want to use an external vault to go store things like HashiCorp Vault, for example, you can do that, but you store the secret to your vault in GitHub Secrets, and then you use that to connect through to your, your other secure store if you want to store them in a different product as well. No problem at all. So yeah, it's great for that. Your scripts have those secrets made available to them when they're running. They're available as environment variables, so they can get access to them just simply through going straight to the environment. The secrets are deliberately obfuscated from logs and things, so if you output a secret, it'll get like asterisked. But apart from that, it's fairly simple. Typically, you scope them at the repository level. You can define them at the organization level. So say your Azure publishing keys, if you didn't want to make those available or something like that, you can make them available at the org level. And then all of your child repositories could have access to the ones you provide at the org level. They get them for free. They're just available. And then a repository overrides the secrets that are stored at the org level. So if you have a secret with the same name, that will be replaced at the repo level by the one that was stored at the org level. And then similarly, if you define an environment, the secret you define at the environment would replace any that you define with the same name at the repository level. So a great example is in a repository, you might define, say, your Azure publishing key. You define that at the repo level for your dev test environment, but then in the production environment, you would override that key with the value of what it is to deploy to production, and only the people who have access to approve runs at production would ever be able to approve code running, which has access to that production key. Does that make sense? All right. Okay, cool. Right. Some limitations for you. Again, we're trying to do like power tips sort of thing. The actions get passed in as environment variables in the steps. They're not passed into workflows that are forked. So if somebody runs like it forks your repo and then tries to run it, they're not going to get access to your secrets, which is both a good and a bad thing. It's a great thing from security. You don't want people deploying to your cloud instances, but also you need to code for that and expect that in the code. Secrets are limited to 64K, which isn't, usually a limitation. It's not particularly a limit, but if you're trying to store something, can't store big binaries in there. So you can usually get away with certificates and things like that, but you can't get away with, some really massive things that people want to store in there. I was having a question. What if you manipulate a secret, convert it to base 64 shift letters, would it remain secret? No. So there's all sorts of ways that, the obfuscation that happens isn't like completely secure in terms of your logs. So general rule of thumb is don't be outputting secrets to your logs. But in case you do, there's some kind of gentle protection there for you. Does that make sense? Cool.
Yep.
It's not magic. Yeah. Right. Okay. So then if we take a look at a basic CI workflow, typical CI workflow, this is one that's, running on Linux. It's going to do a checkout. It's going to do a install and test, and then it's going to, go do an upload. That's the very generic, what CI looks like. With CD, it tends to look a little bit more interesting. So CD is basically, you create the image, you do the build, and then you typically would deploy it somewhere. If you're doing a deployment straight into a package repo or AKS or something like that, that's what it would look like. If you're deploying to Kubernetes, you just go use the Kubernetes deploy, and that uses, in this case, this is deploying to Azure Kubernetes Service. But if you are, wanting to do it command line, you could do that way as well. There's a bunch of different actions for doing that. If you wanted to deploy to OpenShift rather than AKS, there's all sorts of actions for doing the deployments that you want. Equally with AWS, if you're trying to do a deployment there, again, do the build of your Node app, and then you would just use the AWS deploy to deploy out up into AWS. So super simple. That's basically what you end up doing. He's building some steps, go finding the action that needs those steps, and then going and using it is all you end up doing. Again, here's another example of deploying to app service. But if you want to have a practice and a play, GitHub has these cool things called learning labs. So if you go to lab.github.com, you can go play and just go learn all this stuff for free, which is awesome. And it creates like a fork in your repo, and you can go do things and go play with it. So there's 3 labs I've put links to here, and I'll share my slides after this in the Teams call. I'll give you a link to the slides so you can go get all this stuff. But basically, yeah, go do all these things and go have a play with them. It's awesome. Right, next one. Let's talk about runners. How are we doing? Yeah, we're doing great. So there are 2 types of main runners you want to think about. You've got the GitHub hosted ones, so we host for you, and then your self-hosted ones. The way that it works is, we host the images and we go do everything, and we build a clean instance for every job. We manage the scale out, all that sort of stuff. You pay a per minute runtime is what you're paying for that, but there's fixed machine types right now that it runs on. The big machine, reasonably big machines, but they're not unlimitedly big machines. But if you wanted to run self-hosted, so maybe you wanted a machine that had a GPU in it, maybe you wanted to run it on a set of Raspberry Pis, maybe you wanted to run it on premises, you can do that, but you need to self-host those. You need to run those yourselves. GitHub aren't auto-scaling for you, so you're paying for your hosting costs, of running the machine, keeping it up and alive. Whereas with GitHub, you pay per minute, and it's much more of a serverless type model where you pay per usage rather than pay for it always running and always being available. Remember, the GitHub hosted runners are free for public projects as well, not for private projects. If you want to come in and add a self-hosted runner, it's actually really cool. You go to your settings, and there's where you go to actions, and you can add the runner. And then it gives you all the instructions. It's very Unixy, even on the Windows version, it still feels very Unixy. The basic thing that you do is you download and run the script. The difference between Windows and Linux is on Unix, you do a bash script to go install it. On Windows, it's PowerShell, but it's basically the same sort of process. It's very, go run a script. You configure and authenticate back with your project, and then it's running and starts listing for jobs. It just runs as a node process, listening out for, a new job to come and run it. This means it runs on-prem. So if you're running, because it's connecting back out to GitHub over HTTPS, if you're running it inside your network, you can do that, and then that machine then has access to all the other machines inside the network to do deployments and things like this. But you are connecting out from, it connects from your machine out to GitHub. There's GitHub Enterprise Server is now, hopefully within hours, GitHub Enterprise Server 3 will be available, but release candidate is currently out there right now. The general availability will be available pretty soon. I'm hoping, fingers crossed, if everything goes well today. But with GitHub Enterprise Server 3, you can talk to GitHub Enterprise. You can talk to a GitHub instance inside the firewall as well if you wanted to. But usually you're talking to it outside the firewall. Quite often you are. Victor had a question. Can you use PowerShell on Linux as well? Yes, you can. It's actually installed by default on our standard Linux hosted images. But if you're using a self-hosted image, you'll need to make sure you install it. You can do it. It's not as common. Most people use, a shell script on Linux, and but obviously PowerShell is much more common on the Windows boxes. But you can if you want to. Great. When you're doing these private runners, you can group them. It's basically like a label, but you can put them into groups, and that way you can share like a pool of machines of a certain type, and you can go get a machine out of that sort of type. A runner can only be in one group at a time, so you can't have one runner in lots of groups. You know what I mean? It's a hierarchy, a one-to-many relationship between groups to runners. right? And then here's a top tip. All of the stuff, all of the runner, all of the images we use for actions is all open source. And so if you want to go look at the code that we use to manage our self-hosted runners, manage our hosted runners, and then use that to manage your self-hosted runners, you can just go use that code as well if you want to. If you want to see our scaling code, everything's just there, you know, so there's no magic, no smoke and mirrors. You can just go look at the source code and take a look if you want to. Also, all of our images are available as well. So if you want to know exactly what's stored on an image, if you want to create an image that's identical to our hosted images, but with 1 or 2 extra prerequisites, you can just go to those open source repositories, run the scripts that we run to create our images, and then go do your extra bit that you want to go do. And you can automate all that as well, obviously. So that's pretty cool. People don't realize how much of all the action stuff is all fully open source, you know, so just go poke around and have a look. Yeah, right. Okay. Time check, doing great. I'm going to whip through some super pro tips from me, and then we're going to go have a play and have a demo and go look at some stuff. So the first one is using secrets. This is, we didn't kind of show you in big how you use it, but it's just an environment variable, really. Secrets dot, and then you go grab your credential or whatever you want to do. You just go grab it there. Anything that shares that name, you know, so if you override that Azure credentials secret in the repo or in the environment, then that then gets that value. But that's how you get that value out of out of the data into your script. If you want to trigger an action externally, so if you wanted a button to trigger an action, for example, you can do that very, very easily by having it send a web request, a post message to repos owner, repos dispatches, and then you type what the event type is and the client payload. That will trigger the repository dispatch trigger. So you can trigger actions from anything. So if you want to integrate anything else into actions and just go make actions go do stuff for you, you can by using these webhooks. And this is where I said early about some people kind of abusing or using actions in ways we hadn't quite imagined. This is a common one where they're triggering it from all sorts of crazy things, and it's like, we're kind of designed for open source ones, the public ones. If you're paying for them, if you're doing private, go for it. But remember, if you're using it on a public repository, anything you're doing is also backing up the queue for an open source library that wants to build, so use it responsibly. If you want to trigger workflows manually, you can enable that in your workflow by adding a workflow dispatch trigger, possibly the worst named trigger I've ever heard of in my entire life. But there we go. Workflow dispatch is the way to do manual triggering. You can actually pass through variables at this point as well and define variables, and then we get some UI to see them. I'll show you that UI in a moment. If you want to run things with the cron syntax, you can. There's a cool thing in the UI where you hover over it and it'll actually give you like a tooltip of what the cron syntax means. Because I don't know about you, whenever I need to write scheduling syntax in cron, I always have to like go to Stack Overflow to figure it out. So there's got a cool little helper that'll help you do that. Here's my top tip. If you're running a scheduled job, don't get it to run on the hour, because that's what everybody does. It's like when you're picking lottery numbers, don't pick the same lottery numbers that everybody else picks. So rather than, if you want it to run on the hour, like don't make it run 00 like on the hour, make it run 17 minutes past the hour or 33 minutes past the hour. You're much more likely to have a short queue time at that point, because literally everybody is running them on the hour. We see these massive spikes in traffic on the hour and on the half hour on every 30 minutes. So, don't pick the hour and go for a random time that's within the hour, and you'll find your queue times are a lot shorter. If you want to specify dependencies between jobs, so remember how I had like my deploy to production was dependent on my deployment to staging early in one of the other screenshots. You can do that by using the needs keyword, and that means that job 2 won't execute until job 1 is finished successfully. and then job 3 won't execute until both job 1 and job 2 have finished. So this is how you chain jobs together. And rather than them all running in parallel, you can have them run in series, or you could have some of them run in parallel and then come together at a certain point. And that's what that looks like. So that in this example here, I've got the web job, build web, lint web, and unit test are all dependent on that one. And then verify web is dependent on these 3 completing successfully. So these 3 can run in parallel. This one triggers, these 3 run in parallel. Then once all these 3 are finished, this one can then run. This one is like the server side, and that just runs independently. That doesn't need to wait for the web tier to finish at all. Right. If you want to run a job but have some conditional logic in based on the status of the previous step. So for example, if my previous step failed, then go email somebody to like fire off a red klaxon and, you know, make everybody come because we've broken the build or something like that. You can actually do if there's an if condition. So you can now make, you know, if statements and conditional logic in YAML, which is like the worst thing ever in the world, but people need it. So this is a great way of abusing YAML to do programming when you probably should use a different language, but it works fine. So if failure, go do something. And there's failure, success, cancelled as well as always, which is pretty cool. And then this other, nearly my last top tip is if you want to run, like, rather than write a whole action and go do a whole bunch of stuff, if you just want to write some quick logic to go do something, you can use the GitHub script action, which will allow you to run JavaScript, which also has access to the full GitHub like object model and API and things, with access to your GitHub token, to your credential. So you can go do stuff back in your GitHub repo with the, you know, with the security context of the person person running that action. You can go talk back and go communicate back in, which is pretty cool. So yeah, so you can and the script one, you'll see lots of, like, you know, you can do all sorts of hacktastic things, all sorts of amazingly crazy things within a GitHub script action. Debug it, make sure it works. Quite often you then want to take that out and turn it into an action of its own. But if you want to just play, sometimes using the GitHub script action is the quickest and simplest way to get something working and try something else out if you don't want to reuse the code later. I mentioned about steps, and steps had access to the data that was on that VM. But what if you wanted to pass data between things, or what if you wanted to cache stuff? So you're only building things if you need to. We have the ability to do caching. There's a whole bunch of stuff, but you can cache dependencies that are there, so you can not execute something if it's in the cache. So you go check if something's in the cache. If it is, I'll use it. If it isn't, then I'll go build that thing and then execute. And that allows you to quite often speed things up by using the cache and storing things in the cache. You get 5 gigabytes of cache size. So that's quite a lot of artifacts you can actually cache in there between runs, and they're persistent for 7 days. You can store something in the cache and it'll stay there for 7 days, which again massively speeds up, you know, runs and can do things. It's scoped between on a key in that branch, so you can have lots of different names, and you know, it's not other people, other actions inside of that repo could pull data out. So you don't want to be storing like PII or anything, like you don't want to be storing secrets in the cache. That's what the secret store is for. But you can store things like binaries and all that sort of stuff, you know, things that you're generating as part of a build, things that take a long time to generate, then happily store those in the cache. Here's something we added just last week, which I know a ton of people have asked for, so I wanted to make sure I mentioned it. And that is, if you want to check something in, if you want to push something, but you don't want it to trigger a big CI process, maybe you're editing a README file, and you're like, oh, if I do this now, it's going to like use up a bunch of build time and all that sort of stuff. If you put skip CI or no CI, any of these keywords in square brackets, if you put them into your commit message, it will not trigger the push or the pull request triggers. so they'll get skipped that particular run. So there's a little hack. If you don't want something to actually run CI, just say skip CI and it won't run for that particular instance. So hopefully that's helpful. You can switch off your CI triggers if you want temporarily, but it's easier just to do that quite often. And then final little tip before we go play is if you want to go write your actions, there's a cool UI within the website which has autocomplete and a bunch of other cool stuff. But what if you were using Visual Studio Code like we were talking about earlier and you really like Visual Studio Code for editing things? You can use Visual Studio Code to edit actions. There's a cool actions extension for the Visual Studio Code, which is written by Chris, who is actually on the actions team himself. This is an open source project he does in his spare time, but it's somebody who knows what they're doing, kind of thing. And yeah, it's cool. It's not only has it got a bunch of autocomplete and all that sort of stuff, it also gives you the ability to see action runs within the Visual Studio Code UI and all sorts of cool stuff. So definitely check that out if you use Visual Studio Code and you like actions. It's worth a look. Right, and if you want to go try it out, go look at github.com/features/actions to go learn more. And again, a bunch of resources. One thing I will show you is if you go to dev.to/GitHub, my friend Brian Douglas is currently doing a series of 28 days of actions in February. And there's a video along with a blog post of lots of different actions tips and going through like loads of different things. I guarantee you will learn stuff. I've learned stuff every single day so far about actions. So definitely check that out. And then again, I'll drop a link here, but we've got a bunch linked to all the documentation and the forums and all that sort of stuff. Right, I'm going to go play. If anyone's remember at Martin Woodward, if you want to go to Twitter, and then martinwoodward@github.com. I'm going to keep the Q&A window up here while we're playing. But yeah, we're just going to go play for the next 10 minutes or so. People got questions, feel free to come off mute as well during this time. And also feel free to use a text. I will make sure I keep using that. Right. What should we play with first? I think the first thing I want to play with is, it's very, very similar to Ed's series of actions that he did like a couple of Christmases ago, just updated. So that's a great one. So thanks for sharing that. Right, okay. Ed's also a friend, but there we go. Ed's based in Cambridge, not far from me at all. Right, so if we come in here and first thing I want to do is show you these new environment stuff. So if I go into my settings, we talked about secrets. Wow, this is why I did it in text form. If you go to your secrets tab, this is where your secrets are stored for your entire project. So for instance, here I've got like an API key, a cloud deployment key, Heroku token, that sort of thing. So they're stored at the repository level, and you can see down in environment secrets, I've actually got some environments set up. So I've got production and staging. I'm actually going to go straight to my environments and show you those. So within environments, I've actually got quite a few, but if I go to staging first of all, my staging environment has a different override for both the API key that I'm using and my cloud deployment key, so where I'm deploying to. So it's got two different ones there. And then my production environment, it has production. It has different secrets for deploying to staging, for deploying to the cloud, because it's a production instance. So deployment key. Notice I can't read these, but I could update them with a different one if I wanted to. And what this one also does is, before I deploy to production, I need to get a reviewer from somebody in octacademy.dev. So somebody needs to approve this deployment for me. So if I wanted to create a new release, for example, the way I have it set up is I have it set up on a release trigger. So I'm just going to come in here to releases, and I'm going to say whatever my latest CI build is that's running right now, I'm going to create a new release, and I'm going to say tag. I'm just going to tag this like release it. Let's just stick a date on it, whatever. 2021 it is, isn't it? 02/16/01, that'll do. And I'm going to say DDOG deploy. Let's not do it in uppercase. We don't need to shout. You can describe, do your release notes, all that sort of stuff. I'm going to hit publish release. Well, what creating a release in GitHub does is it creates a tag for your code, and it also creates a binary zip file. It creates a zip file of the source code at that point in time. You can attach into that binaries, so like the version of code, you go build it for that release. But what I've done is by triggering this release here, by creating a new release, that has triggered my action, and we'll go look at my action in a second, the code for it, which is going to go do the deployment to staging. So if I click on here, it's probably already finished deploying to staging. Let's have a quick look. Because it's been super slow. Oh no, still deploying to staging. That's good. So you see it's doing the minification and bundling. It did those. It's deploying to staging, which is now finished. So I could click on that and it would show me my staging environment, which is currently running, and it's doing all the compilation, all that sort of stuff when you do the first deployment. So it come back. And then it's saying my deployment to production is waiting for review. And if we notice here, it sent me an email. It sent me an alert to my phone and my watch. But what it's also done is it's given me a little like noted bit of the UI here. So I can review that deployment and I can say, yeah, let's ship it. Let's go into production. So I can approve that release into production. And now it'll kick off the next stage. It go on to the next stage of this execution of this process. So approve and deploy. Well, actually, I'm going to close this window here before it doesn't slow things down too much. And then, we can see it. And we can see who approved it, why they deployed it, what changed, all that sort of stuff. You can follow it through. And yep, it's been deployed out to production. So that's cool. So how does that work? Let's go look at the code behind that one. GitHub work. I'm actually going to go to here, deploy, and we can see we deploying on release type of published. We're going to say minify and bundle, and actually it doesn't do a bunch of stuff because I wanted it to be quick for my demo. So all I'm doing is I'm actually executing a script which just does a sleep because I wanted to pretend I was deploying rather than actually deploy. But that's what it would do. So that's how it works. But you see what I've got here is needs. So my deployment job only runs once build and docs jobs have been finished. And then my deploy to production job, it needs the deploy to staging job to have been done. This is where I specify my environment, and I'm just give it a name and a URL. And that's the URL that's shown in the UI, and the name is just a random string. And then you associate the secrets with the name for your environment. So it's super simple, but out of these simple things, you can build up very, very complicated workflows pretty simply and pretty easily. Now here we've got this release type published. What if I wanted to be able to manually trigger a deployment without creating a release? Well, maybe that's how I want this particular workflow to come. I can just come in here, do edit, and then I can go create a new trigger. And I can come in and do, it's been super slow. Let's just get it. There you go. So I can say workflow dispatch. I can create a workflow dispatch trigger, and I'm going to just check that in. Yeah. So I've now created a new trigger called workflow dispatch. So now when I go to actions and I go to my deploy, I'm just going to do something here. This won't quite work, but just trust me on this one because I was doing some stuff in a demo earlier and then didn't reset it. So there we go. Right. Now when I go look at my deployment, you see it's got now a little run workflow button. So I can come in here and I can manually trigger a deployment. So it sees the presence of that workflow dispatch trigger. And then from that, it'll allow you to trigger the deployment. If I wanted it, I can specify variables, and then it would ask me for the variables here as well that it wanted. I hit run workflow, and then that's going to manually trigger that workflow now. So that's pretty cool. Right, let's go look at some of the other cool new things. So that was visualization, that was environments, that was environment secrets, that was workflow dispatch. That was a bunch of things that we just saw there, which is pretty cool. What I wanted to quickly show was the matrix stuff. So here I have a very complicated matrix example, which is actually in Ed's GitHub Actions Advent Calendar that I've just linked to there. But if I go into here, I've got a few different ones here I wanted to talk about. If we get time. First one is matrix. So this is me coming in. What I'm doing is I'm building up, rather than just a matrix of operating systems like run on Windows, Mac, and Linux, whatever, I'm saying I want a matrix where I've got 2 different versions of a C compiler, 3 different versions of curl, 2 different versions of a Kerberos library. And then I want to run this job for all of the different permutations of those. And it'll kick them off in parallel and just go run them. And anywhere where I use that, it'll substitute that variable in, like Kerberos or curl, and use that for all the different versions that are possible. So if I've got a manual trigger on this. So if I come here into my actions, I just, matrix, I'm gonna manually trigger that and watch it run. Click on this. We can see, I mean, this was actually doing real stuff, so it's going to do some real work here. But we can see this is how it visualizes those 12 jobs. But what it's doing is it queues up, it says, I want 12 build servers, please, because it figures out all the different combinations of those 3 variables for me. And now it's going to run them all in parallel and then tell me when they've all finished, and it's going to come back and do that. So that's that running. We will let that run and then we'll come back. Oh, look, first one's queued up already. Hang on a second, let's have a quick look. First one's queued. Let's see. We're not going to watch it all run, but we'll watch them run and then we'll see. Quite often you get a bunch of builds kicking off at the same time, but they all run whenever it can get a free build server to go do it, non-deterministic. Right, the other action I wanted to show in the 2 minutes, and then we're going to go to Q&A, is this is one our team use every single week. So this is why I wanted to show it to you. And this is an example of triggering off something that isn't a build or a release or something like that, not related to code. What we do on our team is every week we create an issue. Oh, sorry, that's the wrong one. Top 5, here we go. Because my team's based like from Australia, all the way from Australia all the way to Pacific time, there isn't a single time where everybody in my team is awake. And so we want to do like stand-ups and what we're working on and things like that during the week. We want to do that asynchronously. So what we do is we have a cron job which runs at 13 minutes past 1 in the morning, because remember, that's when you're likely to get a free build agent if you run at a strange time. And it comes in and it creates an issue using an action that we've written. And it creates an issue using a template. And then there's the issue template here. And basically, that issue template is YAML again, but YAML front matter, and then some code. And I'll quickly show it to you. What that does is it creates an issue. What you're planning to do, and let's just come in here so you can see what the YAML front matter looks like. Nicer. What do you want to do and who you want it to assign to. So it creates an issue. It assigns it to everybody on the team. And it tells them, what are you going to get done this week? And so then if I go to issues, you'll be able to see there's always an open issue on my team of what are we going to do this week? And then that's where we write our top 5, like what we're going to do. And so that's a cool little way of doing like stand-ups and things like that, just by using actions and doing asynchronously. And it's a cool new feature as well now, where if I do this and demo to DDOG eat cookie, you see when I press return, it's automatically now putting in my checklist and things, because that's a new feature we just added a couple of days ago in terms of being able to do markdown lists and all that sort of stuff. So cool. Right, that's me done of demoing some new stuff. Any questions? I'll open up the mics and open up Q&A and questions.
Well, I have a question.
Cool.
Like you said, there are a lot of actions available because the community can deploy actions, make them available on the marketplace. And there are like a zillion actions out there. There's so many options. But you often see that people have written actions for the same thing.
Yeah.
So what would your tips be to navigate your way around the marketplace, to find the actions that best fit what you need without reinventing the wheel yourself?
Yeah. So that's a great question. There's a couple of different things I look at, if I'm honest. So let's just show you the GitHub Actions. So I'll show you the problem and then I'll show you what some of the things that I do. So from Richard was asking about test result visualization. That's definitely better in Azure Pipelines right now. They're looking at adding that capability into GitHub, but it's not there right now. So yeah, that's a cool feature about Azure Pipelines for sure. So say for instance, if I type Gradle in here, so Gradle's a popular like Java build sort of thing. If I come in and I do a search for Gradle, you see we've got lots of different Gradle ones, but there's a couple of different things. This is Gradle command, which has 110 stars. So therefore is popular, because lots of people have starred it. But also we have this Gradle wrapper validation, which is an interesting one. Validates Gradle wrapper jar file. So that's like from the Gradle project by Gradle. And you see this little tick. It's actually it's a verified creator. So I know that that's like a verified, comes from the project. And it's got 91 stars, so I know it's popular. Whereas this one here, it's got 110 stars, so I know it's kind of popular, but it doesn't have, it actually does slightly different things. So yeah, that's how I do it. I look at the stars and I look at that, and then the other thing I actually go do is when I come in, I'll go look at like who's been contributing to it and go look at how active the repo is to see if it's like commonly updated and all that sort of stuff. So. But that's the problem when there are, let's have a quick look, 7,500 actions in the marketplace. Let's get rid of, let's get rid of Gradle. Hang on a second, come back to the, come on, it's been super slow. All right, let's try that instead. Let me know if there's any more questions.
You see some frantic typing in the chat, so
yeah.
Let's see what's coming up. No pressure.
$7,236 actions right now. One thing that is quite cool though is like the GCP ones by Google. The AWS one is by AWS. The Azure ones are by the Azure team. The Docker ones by Docker. So you quite often find that like the Jira one is from Atlassian. Because it is so popular and there's so much traction that people are coming in and making their own, which is cool. Thanks. I'll let you wrap up then, yeah, but I'll be around and then I'm on Twitter if you've got any questions. I'm just going to post a link to this slides now and then I'll drop that in this Teams chat here. But yeah, thanks everybody for your time.
Thank you very much for your time.
Yeah.